15 Juni 2020. Dan Pak Direktur ini luar biasa karena pesertanya itu rata ya dari seluruh Indonesia sampai ada perwakilannya Pak. Ada dari
PKRP webinar.
dan tentunya para sahabat saya yang untuk memulai acara ini sangat berbahagia semua jika bersyukur
Good morning, good afternoon, and good evening, ladies and gentlemen. My name is Ahmad Yunus from International Affairs STIKI Malang, Indonesia. It is my pleasure to welcome you here in this international webinar 3. The today's webinar is collaboration between STIKI Malang, Indonesia and Satyabama Institute of Science and Technology, Chennai, India. There are 2 sessions in this webinar. First session, we have Dr. Parati from Satyabama Institute of Science and Technology, India, with the topic Machine Learning, Trends, Perspective, and Opportunities. In the second session, we have Mr. Adin Aditya from STIKI Malang, Indonesia, with the topic Sharing Session, Systems Thinking, and System Dynamics. The moderator is Ms. Susana Pudiastuti, the head of Office of International Affairs STIKI Malang, Indonesia. Before we start, I would like to inform you the rules of the webinar. The first, please turn off your camera and mute the microphone for avoiding connection problems and noises. 2, please type your name, institution, and email address in the chat box for recording your attendance. For a participant who was registered via Ngampus application, please type Ngampus before your name. For example, Ngampus, and then your name, institution, and email. Chat in the chat box for asking questions to the speakers. Please follow this webinar till the end to get e-certificate by filling out the exit ticket. The link to the exit ticket will be informed at the end of the webinar. Let's get the ball rolling with the first session. Ms. Susana, the screen is yours.
Okay. Good morning, good afternoon, good evening, ladies and gentlemen. I'm so sorry that I have technical issues with the camera here. But first of all, I would like to thank you for your participation in this international webinar series season 3, which is organized by Office of International Affairs of STIKI Malang in collaboration with Satyabama Institute of Science and Technology, Chennai, India. I am Susana, the head of International Affairs of STIKI Malang, Indonesia, is the moderator of this webinar. Our today's webinar is divided into 2 sessions. The first session is presented by Dr. Bharati from Satyabama Institute of Science and Technology, Chennai, India. And the topic being presented is machine learning, trends, perspective, and opportunities. And the second session is on system thinking and system dynamic, is delivered by Mr. Adin Aditya from STIKI Malang. Before we start with the first session, allow me to read a bit resume of Dr. Bharati. She is a qualified education professional with more than 16 years of experience in primary and secondary learning environments and a wealth of knowledge in development and implementation of educational technology tools, research and administration. She earned her PhD from Satyabama University, Chennai in 2012. Her research interests include software engineering, performance evaluation, software architecture, software testing, predictive analytics, machine learning, IoT. Her research has been published in many journals, both at the national level and international level. I've just got information from Dr. Bharati that she is having a problem with the network and he is not able to log in. So I think that we can switch to the second presenter first with Mr. Adin Aditya from STIKI Malang. His topic today is about system thinking and system dynamics. And allow me to read her resume. He is an experienced lecturer with a demonstrated history of working in the higher education industry, skilled in research, Java, PHP, system dynamics, and Microsoft PowerPoint. He has a strong education professional with a master's degree focused in business process management and multi-criteria decision making from Institut Teknologi 10 November Surabaya. So I hope that Pak Adin is ready for taking the first sessions of this webinar because of the network issues facing by Dr. Bharati. Pak Adin?
Yeah, Susan.
Is it okay if you start first?
No, it's fine. It's fine.
It's fine. Okay. Okay. So for all the presenter, I want to remind you that you can ask questions to the speakers or to Mr. Adin in the chat box. That is me, and I will give the time to Pak Adin. Okay, thank you, Pak Adin. The screen is yours.
Okay. Thank you, Bu Susan. Good afternoon, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I would like to say thank you for joining us in this seminar. First, I would like to say thank you so much to STIKI Office International Affairs for letting me join this event, and really big appreciation to Satyabama University of Science and Technology. It's very nice to see you, Dr. Bharati, and I hope we can share about our material. and really wait to your material about machine learning. Okay, in this opportunity, I would like to share about you. I'll share to you about system thinking and system dynamics. So before we start, I would like to introduce myself. My name is Adin Aditya. Ms. Susan already said my name is Adin Aditya, but you can call me Adin instead. I finished my master's degree in computer science at Institut Teknologi 10 November, Surabaya. And this is my area of expertise in modeling and simulation, software engineering, and enterprise system. So this is my two publication related to our material this afternoon. So I would like to I will share this publication later. And so I'm going to split this presentation into 3 parts. And first, we will talk about the fundamental of system dynamics. So why is system dynamics? What is system dynamics? And how system dynamics will help us to describe our phenomena. And next, we will try to understand the formal method how to work with system dynamics. We start with how to draw a Causal-Loop diagrams and how to formulation a policy and strategy through the stock and flow diagrams. So the summary is why we choose system dynamics for our research tool and how system dynamics will help us to finish our research. And the last one is after we understand the entire of fundamental of system dynamics, I expected to you can imagine how you can do the research with system dynamics and what area can we achieve, area of research can we achieve with system dynamics. So I thought you will not strange with term in system, model, and simulation. So so why do we need system dynamics? So why do we need model, system, and simulation? I'm sure the answer is not simply that the world is changing faster and faster. Things accelerating and everybody knows that. It's that despite all the tools and methods that we've got, all the analytics power and cleverness, things are getting harder and harder. And more, and the policy that we have implemented are failing to solve the problems that we face. So with the model and simulation approach, experiment and training will less of risk, easier and low operational costs. So if you work as a manager and you want to decide a strategic decision, you will face several risks, right? So and you don't want to do that. You don't want to decide that you don't know is there any risk, is there any chance of failing of my decision? It's very difficult to work with a real system with a huge cost and safety risk. What if I decide one or two strategic decision and then it will be due the chaos for our company. Now take a look at this picture. From this picture, what do you think? Let's say that you are a operational or top manager and you have a problem to decide what is better for your company. you have so many problems. So you have to decide what kind of problem, what kind of decision to that can be solve this problem. In this picture, this manager take a short-term decision to push on the blocks and at the left side. So he think the problem is solved. Is solved? Yeah, for sure. For now, for short-time decision, it's quite well. But if you have to think big, think bigger, this decision can make more can make other causality for your company, especially for you as a manager. So in system dynamics, we have advantage and disadvantage for using this research tool. First, there are an opportunity other people will do the same theme of research. System dynamics is like, what is it? System dynamics is it's a macro research. It's macro research. It applicable with all majors, whether it's social science, engineering, psychology, mathematics. You can do all the research with system dynamics. So don't be so surprised if other people can do the research with same theme or same model. Next, system dynamics is lack of novelty, especially in Indonesia. Many countries in like Australia, America, Europe, they use system dynamics, and other discipline said that system dynamics have good novelty, but not in Indonesia. In Indonesia, system dynamics is, especially for information system major, system dynamics is like have bad novelty. I'm say lack of novelty for master student and doctoral student. But you can get more value from novelty if you have to visualize data. System dynamics need a verification and validation in several steps. So if you build a model and simulation for real system, you have to verify the model. You have to validate the model. So the model can represent the real system. System dynamics doesn't always represent the actual system. Why? Because system dynamics is like have a large variable depending on your case study. So if you have to do the research with the 100 variables, so make sure that you can do the verified and validation steps. System dynamics is a serial data research, so make sure that you have dynamics requires serial data with a span between 5 to 10 years. So if you have do the forecasting, for example. So forecasting the requirement of rice production. So you have to looking for serial data with a span between 5 to 10 years. Okay, so the last advantage is system dynamics is applicable with all majors. Whether you are social science or you are an engineer, you're a doctor, you can use system dynamics for your research. I'm sorry, you can feel free to ask if you have any question, yes. So, simulation method. There are 3 points of simulation method. There are system dynamics, discrete event modeling, and agent-based modeling. But in this opportunity, I will like to share you about system dynamics. So maybe I will try to describe discrete event modeling and agent-based modeling in other session. So before we start to discuss about system dynamics, I would like to do the same thing about system thinking. I'm sure you're not. This is a popular terms. System thinking. System thinking is a way of thinking about and a language for describe and understanding the force and interrelationship that shape the behavior systems. So if you try to model, what would you do? What is happening now in your mind that you have? Then you already do the system thinking with one variable goes to another variable. So this is essential of system thinking. System thinking is discover interdependent relationship, influence and feedback, not a single direction of causal relationship. So if you love me, then you love me back. That is system thinking. Looking at the behavior of the whole system. System thinking is have a macro view. So they talk about what variable cause another variable. So this first illustration, laundry thinking. Laundry list thinking is defined by a set of 4 meta assumptions that are used to structure cause and effect relationship. So take a look at the picture. If you want to achieve your success in academic field, you need to have a good teacher, you have a good parenting, you have a high motivation, and you have positive classroom environment. If you have these 4 points, then you achieve your academic success. Is that right? But this is laundry thinking, not a system thinking. Now take a good look at the next picture. This is closed loop thinking.
Bau kecut.
I'm sorry.
Duduk ata. Andika.
Sorry, could you please
Obatku yang tremor belum tak minum loh. Iku nang kono.
Udah tinggal.
Okay, I'll continue. So take a good look at this closed loop thinking. So different with laundry thinking, if we have 4 variables to support your academic success, this closed loop thinking has also have 4 variables to support your academic success. Good teacher, good parenting, high motivation, and positive classroom environment. But take the direction of each variable. Good teacher have a positive influence to support academic success. Academic success has good influence in good teacher. So closed loop thinking is the real world is seen as a collection of interdependent processes that continue over time. The real world is not seen as something caused by a one-way relationship of set of factors. Different with laundry thinking, it has one direct relationship: good teacher to academic success, good parenting to academic success, high motivation to academic success, and positive classroom environment to academic success. They have one direction relationship. But closed loop thinking, they have not one-way relationship. They have a they have a causality for each variable. If you have a picture, if you catch a big picture for system thinking, then you can go to the system dynamics methodology. System dynamics methodology is how we describe phenomena from each variable, how we describe this variable influenced for another variables. So, system dynamics is introduced by J.W. Forrester in the 1950s and based at MIT, America. As the name implies, this method is closely related to questions about the dynamic tendencies of complex systems, namely the patterns of behavior that are generated by the system following the increased time. System dynamics has a dynamic nature. It affects by the time. So if you have to do research that the variable affected by the time, system dynamics is the solution. Phenomenon structure contains at least one feedback structure. So if you have to describe phenomena, one variable influence another variable and contain at least one feedback, so you can use system dynamics. So this simple illustration. So if we have several variables in here: environment information, actors, accumulation of information by the system, updating information, new emerging information, and action. So if you as an actor, you as a manager, you as a top manager, middle manager, or low manager, and you have to decide something to your company. You have to collect data and information, right? Data can be collected for information, environment information. Data can be collected from accumulation of information by the system. Then you as the actor on your organization can use that information for decide something for your organization strategy. So the first step to do the system dynamics research is draw the Causal-Loop Diagram. What is Causal-Loop Diagram, or CLD? CLD is model block builder that represent through the closed circle. That feedback loop declares the causality. Causal-Loop Diagram has two different causality: positive and negative causality. So the example of positive causality is like if you for example, in some country, if the birth variable increase, so the population is increased also. Population increase, so the birth rate is increased too. Is that is this a normal causality in our life? This is positive causality. Every variable give a positive feedback for another variables. So take a good look at negative causality. The mortality gives negative cause for population. Price variable gives negative cause for consumption. So this is normal causality too in our life. Mortality of death can decrease the population. The high price can decrease our consumption. This is negative causality. One variable give a bad influence to another variable. I repeat one more time. For positive causality, one variable give positive influence to another variable. Like birth give positive causality for population. Mortality give negative causality for population. If mortality more increase, the population more decrease. So this is how you draw Causal-Loop diagrams. So if you have two different variables that give positive causality, so you can add mark plus in the middle of the variables. But if you have two or more variables that give negative causality, so you can add negative mark in the middle of the variables. So after Causal-Loop diagrams is proposed to describe the phenomenon, the big picture of the phenomena. So if you have to describe to other people how these phenomena work, you can draw Causal-Loop diagrams. The point is Causal-Loop diagram is for informational purpose. They have no to input data. They have no to input formulation in systems in Causal-Loop diagram. So the Causal-Loop diagram is need to inform the other people how the phenomena works. Next, after we talk about Causal-Loop diagram, talk about how the phenomena work, then we draw stop and flow diagrams. What is stop and flow diagrams? Stop is a variable that contains the formulation of several variables. Flow is a variable that measures another variable with a unit of time. So, for example, gross domestic products. Gross domestic products is a stop. What is factor that drive the increase of gross domestic products like consumption, investment, government expenditure, export and import, something like that. So in this illustration, if we have like a bathtub with what is it? I'm sorry. With some water to tap water to flow the water. Bathtub is a stop. Bathtub is a stop, and tap water is a flow. Bathtub is a stop. Water is the data, and the tap water is a flow. What many factors that drive increasing the data? So water in tap water to flow, give a positive causality for bathtub, and water flow into sink when after you finish your bath, you can you flow the water into sink, right? So water flow into sink it's a negative causality for stock. And so if you can take a look at this chart, water and time, and if sorry, oops, yeah. So stock and flow diagram to describe how this data flow from tap water to sink. So after, stock and flow diagram is proposed to describe how the data can drive the causal loop diagram and to describe more detail from causal loop diagram to stock and flow diagrams. So the simple point is stock and flow diagram is more detailed than causal loop diagrams. If you have to describe more detail from another part of causal loop diagram, you can use stock and flow diagrams. Okay, so after we can describe the stock and flow diagrams, we developing a policy scenario. After we can modeling the data from stock and flow diagrams, we developing a policy scenario so the top manager can use this scenario to decide a strategic decision. For developing a policy scenario, we have two options: structure scenario and value scenario. If you have to choose structure scenario, then you build a new stock and flow and causal diagram for a better decision. But if you have choose the value scenario, you use the existing model and you input the new value. For example, if we have sorry, I will take you to so this is causal loop diagram. This is causal loop diagram. I'm sorry to use Indonesian language here. So each variable give another causal for each variable give causality for another. So if you have to choose value scenario, you use this model and give new value. This give new value like this. But if you have to choose the new, if you have to choose the scenario structure, then you can take the new view one and you draw the new stock and flow diagrams. This is the difference between structure and value scenario. Like if the software engineering view, structure scenario is you have to build a new one with the same purpose. But if you have to choose the value scenario, you use the existing software and you can add more additional value for that software. For policy scenario, we have three different kinds of scenario. First is pessimistic scenario, most likely scenario, and optimistic scenario. Pessimistic scenario is the way you think that this scenario is fail to achieve its purpose. And most likely scenario is this scenario is do nothing. You add more value, you draw the new causal loop diagrams to you can add more variable, but there are no changing. This is most likely scenario or do nothing scenario. But if you choose optimistic scenario, then you add some value that give this scenario is better than its purpose. This is policy scenario. And the last one, if you have to choose, if you want to try research in system dynamics methodology, you can choose whether supply chain management, project management, or human resource process and dynamics for of improvement. System dynamics is from industrial management, I think, and but it can be used for psychology major, mathematics, physics. It's applicable for all major. But for the last 2 years, as a lecturer and researcher, I got so many point of view of system dynamics from supply chain management, project management, and human resource process and dynamics of improvement. But if you have to try with system dynamics, you can choose other majors. This is not a limitation of research opportunity, but you can try the system dynamics for other majors. So we have arrived of our course. System dynamics could be used for almost every major, but not fit for research that has no serial time data. So make sure that your research has serial time data. If you want to do the research purpose is to describe the phenomena about the macro research, but there is no serial time data. I think system dynamics is not fit for your research. If your research your research purpose is to describe the relationship between one variable and another, you can use structural equational modeling. You can use linear regression. If your research has no serial time data, I think system dynamics is not fit for you. System dynamics has a limitation of novelty, so make sure if you want to work with it, use another visualization tool as an additional value. System dynamics tend to formulate strategy and policy, yet its novelty depends on the case study. This is for Indonesia only, yes, but if you have to research in other country like Australian, Europe, like Germany, they use system dynamics very well. But especially in major information system, in Indonesia information system is often use the system dynamics. But you can try combine system dynamics with other visualization tool. You can combine system dynamics with other research methodology. The form of the model could be variative, depends on the research objective and its limitation. System dynamics has no formal model for each research theme, so you have much more opportunity to build your own model. This is the main advantage why we have to use system dynamics. If you have to propose your undergraduate or master's degree, you can use system dynamics. Of course, with the serial data time, you can use this model for your novelty. I think it's better to try. So I think that's all for my material. You can ask me about system dynamics through my email, or you can discuss with me, or you can feel free to ask for system dynamics in chat or just talk right now. Okay, that's all. Bu Susan, I give back the screen to you. Thank you. Is there any question?
Unmute me. Yes, thank you, Pak Adin, for the presentations. Okay, Ladies and gentlemen, you can ask questions to Pak Adin directly. We will unmute the participants if you would like to ask questions to him about the system thinking and system dynamics. Or while we are waiting for the questions, I'm quite new in this area, Pak Adin. Could you give, what is it? A practical examples that can be used for the students to, if they want to conduct a research in this topic.
Okay. Okay. I would like to share my research with system dynamics. Just 1 second. Okay, this is my first research with system dynamics. With the title is Multi-local geothermal power plant development strategy in order to maintain the sustainability of supply and demand electric energy in Kupang, East Nusa Tenggara. So the purpose the purpose of this research is to do the capacity planning for supply and demand electric energy with system dynamics framework. So I'm sorry. This is my Causal-Loop diagram. The point is, this research is try to understand the reader how the geothermal potential can fulfill the electricity demand in Kupang, East Nusa Tenggara. So in Kupang, they have a geothermal potential that can be used to as electrical energy. So this research is trying to describe how geothermal potential will fulfill the electricity demand in Kupang, East Nusa Tenggara. Now, this is how I do the system dynamics research. It starts with I draw the Causal-Loop diagram, how each variable can be influenced to another. Then I draw stop and flow diagrams. This is stop and flow. This is stop and flow. Stop and flow. So after I draw the stop and flow, do the validation model. Validation model is do with the two-step mean comparison and error variance. Mean comparison is the comparison between mean of simulation and mean of data. If the mean comparison or E1 is less than 5%, then the model is valid. Or if the error variance, and next is error variance. Error variance is comparison between standard deviation of model and standard deviation of data. If E2 is less than 30%, then the model is valid. The model is valid means the model is represent the real system. So after I try to validate the model is valid. So next, I build the model scenario, parameter and structure scenario. this is how I do the power plant capacity planning using system dynamics. This is the disadvantage using system dynamics. If you have no other visualization tool that you cannot visualize the data better like this. This is a standard visualization from Ventana simulation. This is an application for how we do the model and simulation. This is a This is a standard. This is a standard visualization from Ventana simulation. So if you want to use system dynamics as your research tool, I suggest you try using another tool for visualize your data, such as Tableau Public, such as you can do your own code like TensorFlow. You can do our code using PHP and JavaScript, something like that. Okay. So this is my paper for simulation and modeling. You can try to read that at my Google Scholar. I think that's all, Bu Susan.
Yeah, okay.
Any question?
Yeah, I read one questions from Septama. How to apply the system dynamic in the real case? Does it need to use a specific template, or is that any standard, any other standard that might be used?
Okay, thank you for M. Septama. Bagaimana cara menerapkan sistem dinamik dalam studi kasus real? Apakah harus menggunakan template tertentu atau ada standar lain? Okay, how to implement dynamic system for real case study? Is that any other template or other standard? Okay, system dynamic has no template to any particular study, such as like you can draw your causal loop diagrams for case study, like you can draw to, for example, case study for forecasting the electricity demand in Indonesia, but there are no special template for modeling the forecasting demand. So you can, because every case study has different variable, right? So if you you can have more variation for drawing your model. So it's fine if you have a different model from other researcher. There's no need to afraid about that. If you have good recommendation, good references from your model, so it's worth to draw the model. It's okay. Okay, Cynthia Listio, I would like
Cynthia, unmute.
I would like to ask directly. Okay, please.
Yeah, for me, Cynthia, I will unmute unmute you so you can ask directly to Pak Adin.
Okay,
Please
please,
wait.
Cynthia.
Good afternoon, sir. Thank you for your presentation. It's really give me some new knowledge and also like a new idea for my research. Please, first I want my name is Cynthia. I'm from Sanwon University, Korea. Nowadays, I've been research as a master degree student, and my field is more into machine learning and deep learning. Like, I want to ask you something, since when I hear your presentation about the system dynamic, it said that one important point of this system is you need the data that is time-related data or like time series data, that you also mentioned like minimum of it is going to be like 5 until 10 years data in case of some company. And what I want to ask is like, since you know that nowadays the big data is also have been hot issues in like the research world, and also like since I've been in deep learning and machine learning, is there any possibilities like how to implement some big data method or machine learning method to the system dynamics, and how to tackle a problem with the data, since we know that us as as a researcher is always have a problem with the data. Like it's really hard to find a really big size data and like a data that we can use as a research. Maybe you have some experience you can share with us, like how to tackle a problem with the data, and maybe you know about some system dynamic using machine learning method or deep learning method. Thank you for the time.
Okay, thank you, Cynthia, for the question. I would like to say good luck for your research, and I will repeat your question. Is there any possibility for big data using system dynamics, right? So, for the last 2 years, I do my research in system dynamics. There are no particularly research big data using system dynamics because big data has a special purpose. So they have a special method to do their research. So if you have to use system dynamics, I think system dynamics has no limitation for big data. I think big data can be used. I think system dynamics can be used for big data, but I'm so sorry, I have no experience for using system dynamics for big data. Maybe this particular question can be answered with Dr. Bharati, but for me especially, I'm so sorry, I have no experience using system dynamics for big data. But if I read many journals, I read many conference proceedings, there are no articles about big data using system dynamics. But I'm still learn about system dynamics. System dynamics is like macro research, but I think positively that big data can be used with system dynamics. But I'm so sorry, I have no experience using system dynamics for big data. But I will keep your question. If I have some answer, I will contact you directly. I'm so sorry, Cynthia. Thank you.
Okay.
I hope this will answer your question.
Okay, thank you, Cynthia, for the questions. Is there any other answer from the participants? Not yet the questions. You still can, Pak Adin, will you still be with us until the end of the webinar?
Yeah. Okay.
Yeah, okay. Sure. So Pak Adin will still be here with us. So anytime you want to ask questions to Pak Adin, please chat in the chat box so we can, we can answer the questions for you. And I think that is all for the first sessions. Pak Adin, thank you very much for your beneficial knowledge, or yeah, it's broaden our knowledge, add more to our knowledge related to the system dynamics. And thank you so much. And we can go to the next sessions. Thank you, Pak Adin.
Yeah, thank you so much.
Okay, yeah. I just want to, before we start with the second sessions with Dr. Bharati, I want to inform you that the certificate will be granted to the participant who follow the webinar until the end. And at the end of this webinar, we will share the link to the exit ticket so that you can record your attendance, and also the name the name for, and also the email for sending you the e-certificate. So please stay with us until the end of this webinar. So Dr. Bharati is here with us. Before we start with the second session, please allow me to read again Dr. Bharati's resume. Dr. Bharati is from Satyabama Institute of Science and Technology, Chennai, India. And she is a qualified education professional with more than 16 years of experience in primary and secondary learning environments, and a wealth of knowledge in development and implementation of educational technology tools, research and administration. She earned her PhD from Satyabama University, Chennai in 2012. And her research interests include software engineering, performance evaluation, software architecture, software testing, predictive analytics, machine learning, and IoT. Her research has been published in many journals, both at the national level and international level. Without further ado, let's pay attention to the presentations of Dr. Bharati on machine learning. So if you have any question, please type in the chat box, and Dr. Bharati, the floor is yours. Unmute Dr. Bharati, Hun.
Hello. Thank you, Susanna, for this wonderful introduction. Good afternoon, everyone in STIKI Malang and my colleagues from Satyabama University. I am Dr. Bharati, as introduced, a professor from the Department of Computer Science and Engineering, Satyabama Institute of Science and Technology. And I'm very thankful for this invitation given to me. And I'm very happy to also represent my university and thank my Chancellor and the Vice Chancellor for giving me this opportunity. Thank you. And today I have tried to give you a wide perspective about what is machine learning, what are the various trends in machine learning, and the various prospects in the machine learning field. Now, at this time of pandemic, when the whole world is locked down, it is only all electronic gadgets which are helping us. Even this session is happening online. So if you have any electronic gadget around you, then definitely, yes, it is seeing you, hearing you, and learning information from you. The previous session, as Mr. Radin said, that there is a lot of system thinking happening. So there is a lot of data collection. And all this data collection is happening in the form of the system recording all behavior of us on the network. Say if I type something on Google, Google tries to understand what is my behavior, what is my interest. So even if I type Java, it knows that it is I'm a computer science interested person, so it will never show me results of Java coffee. It will only show me information on programming language of Java. So your computers are seeing you, hearing you, and listening to you always. So what is machine learning? To simply say, machine learning is predicting answers from data. Okay, and we say that this is a part of artificial intelligence where we allow the system to design and develop algorithms so that it can help us in the result prediction process. So the system tries to incorporate the intelligence of a human being, and that is why it is called as artificial intelligence. And in doing so, it needs a lot of data to be collected, the domain knowledge, and we need certain algorithms that can deduce results or decisions from these data which is being collected. And machine learning is the field wherein the algorithms are modeled based on the data, and it helps in our decision making process. So artificial intelligence, as I told you, is trying to mimic human intelligence. A human being has got a lot of memory to accumulate a lot of data. They have their own perception. They also add environmental knowledge as anticipations and apply problem solving skills and make decision making. So if I see a tiger, I know I'll have to run because I have read in books, people have told me, I have seen images or videos or something where it shows me that a tiger coming towards me is not a good sign. It is going to cause me harm. So all that knowledge or intelligence that we have as a human being, when we try to incorporate this into a machine, we actually call it as artificial intelligence, and lately we have started calling it as augmented intelligence. So we need a lot of domain data, and this data has to be processed. It has to be converted into the system understandable format. Okay, so there is a lot of dialogue and conversation by which the system tries to understand the data. Natural language processing is applied to convert all speech to text, text to speech, and computer vision is used to understand various information on the video or images and so on. And there is machine learning playing an important part where it tries to analyze all this data that is being collected and gives us predictions. So definitely a system developed using machine learning algorithm can also tell you that a tiger coming towards you is not a good sign, so please start run. Okay, so many there are so many other fields which are very related to machine learning. So we would say machine learning is a multidisciplinary field. You have data mining in it because I need lots of data to be collected and I have to mine information from my data. There is control theory because you have a closed loop system where you have feedback, or you also have an open loop system. It helps in decision theory. There is cognitive science because I'm going to apply pattern matching, computer vision, thinking like human is necessary. So we also have neuroscience, psychological models, database, collecting information, information theory, applying mathematical inference methods. So it is also called as statistics. So machine learning is totally a collection of so many other fields of science. And there are two different perspectives of machine learning. Some say all these words, statistical inference, machine learning, pattern recognition, data mining, are all one and the same. They're all the same concepts, but just that they are coming from different traditions. Machine learning from mathematics, we will call it as statistical inference. Machine learning from image processing or speech recognition, then we call it as pattern recognition. If we are talking about database engineering, then the same word we say that it can be called as data mining. But is that right? Someday 50% it may be right, because in statistical inference is a mild line between your mathematical concepts of decision making and artificial intelligence. Pattern recognition also involves concepts of machine learning, and data mining is also a field where in the process of mining data or information from large amounts of data, we do apply machine learning techniques. So we have another perspective of the same idea saying, yes, statistical inference is all about model building, and it is a good combination of both mathematics and artificial intelligence concepts. When we talk about machine learning, we talk more about heuristics techniques, where we try to find out which algorithm suits which situation of decision making. Pattern recognition is the best field where you have machine learning applications widely applied. Data mining in machine learning, as I told you, it is generating answers or generating predictions from lots of data. Now, when I take this data, my data can have noise, my data may need lot of pre-processing. So I have to do pre-processing, cleaning, then convert all data into a common format. So transformation of data, we call this as the ETA, extract, transform, and analyze. So all this has to be done. Then I have to derive decision from my data, and then the results that I generate has to be properly visualized. Visualization is more important because the end result of any data mining algorithm is understanding the problem or understanding the information. Now, this is what machine learning also does. So machine learning starts, it is very better to say that machine learning starts from data mining. So why are we talking about machine learning when we already have so many other fields of science which is talking to concepts which are very similar to machine learning? Machine learning is a science wherein we develop algorithms, design and develop algorithms which can automatically inherit the behavior of analyzing the data and coming out with decisions based on dynamic situations. So when a human being can do this automatically, why is the need of machine learning? Machine learning comes into the picture when all this data collection becomes very, very large, complex, or at most impossible, or when there is a need for complex algorithms, or when there is a need for an impossibility of deducing results from the algorithms. So when you cannot directly apply a human expert, like in a manufacturing control design or analyzing a DNA or something, you need a machine learning algorithm to work. In black box human expertise, where you know this is the input, this is my output, but how did I deduce this answer? See, you just by seeing your handwriting, some friend's handwriting, you can easily find out that this is my friend's handwriting. But how did you gain that knowledge? It is very complex to give it out in rules. It is very complex to set some standards saying if it follows A, B, and C, then it is his handwriting. So when there is complex expertise involved, then machine learning comes into place. Driving a car on a road or flying a plane, all these are examples of black box human expertise. And when there is a rapidly changing phenomena, like fraud detection, every day in and day out, there are new types of fraud which is popping up on the internet or in the transactions, in the banking transactions field. Though there are so many solutions for this, every day there is a new fraud coming in. So it is a rapid changing phenomena, and you'll have to understand and analyze this new fraud every time. And for this, we definitely need machine learning. Then comes personalization and customization, which is the need of the hour. As customers across the globe, what we require is personalization. I am not interested in products, or I am not interested in information which is not of any interest to me. I am not going to look into it. So if I'm a computer science person, I will be more interested to see only computer science information related to me. Or say, for example, in Netflix or in Amazon Prime or any other OTP platforms, whenever you watch a movie, the next time you start watching a movie, or when the next time something pops up, there is a recommendation given to you that this movie is 80% closer to your interest, 90% closer to your interest. So this is a personalized recommendation that the system is trying to give you. Now, in such cases, definitely we need machine learning techniques. So when all we use machine learning, we have been, we have come to a situation where our everyday life has machine learning involved into it, either as any application or as a transaction, or in some way we are all related to machine learning in our daily lives, like Google introducing the Google cars. Whenever you search your website, Google website, for some information, Google is the best example of machine learning, where it has got number of machine learning internal systems working to give you the result that you are looking for. Okay. And fraud detection. credit scoring. When you take credits from the banks, every bank is giving you a credit scoring, telling you how good you are in repaying the amount and so on. Okay, so all this information is accumulated to finally find out how good are you as a customer to a bank. So next time you go to a bank and ask for a loan, the bank is going to definitely check your credit scoring and then say, okay, you are a reliable person, you pay back your credits, so I'm going to give you a loan. Okay, and similarly in pattern recognition, when you want to identify anonymous movement in a public place or in a railway station or anywhere, then we go in for computer vision and pattern recognitions. Okay, and all social media application definitely apply machine learning processes, and all OTP platforms like your Amazon, Netflix. Okay, and there is a lot of sentiment analysis and behavioral analysis which is being done by all marketplaces. It's because as a business person, the business person is in need of an information to find out who are those probable customers for me who will look for my product. So the business has started to analyze, understand all your tweets, all your social media posts, all your WhatsApp communications to understand what is your interest. So based on your interest, they are going to market some products to you. So all this is happening only because of machine learning algorithms, which are playing a major role. Even now we are using our Uber apps, Ola apps for online taxi booking, car booking. Okay, and there are number of apps which are helping us in any ticket booking services, etc. So all this is possible, or all this are the latest machine learning trends which are available across the globe. This is a very good example that currently we are using in India, and because we are under this pandemic of COVID-19, the government of India has introduced an app called Arogya Setu. And you will not believe, when the app was first introduced, in just 13 days, it has been downloaded by more than 50 million users. So that is the speed of information passed onto the community, and that is the amount of data that is being collected from the community. Now, all those 15 million users, by using the app, are giving important data about themselves to the government to analyze how many people are COVID positive, what is their living condition, what kind of activities the government has to take up to overcome their problems, and so on. So that is the internet today. That is the amount of networking which is happening today, and that is the role of machine learning to play in any situation that is coming up. Actually, this Arogya Setu is an app which has a cutting-edge Bluetooth technology, and it uses decision tree algorithm also. It is to find out whether the person that who's coming into your closer contact has got COVID-19 or not. So it will alert you, and so that you can stay away from that person. Or in a later date, when he has got a COVID, it will alert you that you have come across a person who has got COVID, so you have to check yourself. So this app is currently widely used by the government of India to understand the pandemic spread now. So in a machine learning system, yes, we were discussing about this little earlier. I have a lot of input samples, and from the sample, I have to find out a learning method that can learn and model itself to give me decisions. So that is what I'm looking for as a machine learning system. Okay. So how will I do this? I'm going to collect lots of data which is related to the domain, which is my get data. Then I'm going to prepare my data, because my data can have noise. There can be some missing information. There can be some redundant information, because of which my results may not be correct. So I'll have to remove my noise. I have to remove my redundant information. Wherever there is a missing information, I'll have to find out what is the problem, and I have to impute values. Now, once I do this, I'm going to train my model, meaning I'm going to teach my model how to understand the data and what type of answers to give based on the set of inputs. Okay. And test data is I'm going to check whether whatever I taught was correctly understood by my system, and I'm going to help the system improve. We can relate this to an analogy of a child. Say we have a very small child at home, and the first time the mother is teaching the child, see, this is showing photographs. This is an apple, this is an orange, this is grapes. She's teaching fruits, vegetables, and all that using photographs. Okay, so if she has to teach, she has to collect all photographs of all these fruits and vegetables, just get data. Then she has to decide which are the most simplest words that the child can understand first. Not necessary that it has to dump the child with too much of information at the same time. So this is your second stage of cleaning, preparing, and manipulating data. Then she starts training the baby. Say this is an apple, it is red in color, round in size, all this. So when learning, the baby also tries to understand with its own environment information. So the next time, even if it finds out an apple on a table, it will say apple. So that is the amount of learning that the system takes, that the child takes. The same is what we try to incorporate on a machine learning system. So after the child learns, say for example, the mother keeps training for over a period of time. And after that, she starts testing the data. How will she test? She will show pictures and say, is this correct? Tell me what is this? Tell me what is this? And every time the baby should give out correct answers. If the baby gives out a wrong answer, the mother always tries to improve the answers. So the same is what happening in a machine learning system. Depending on the training model, we can classify the machine learning algorithms into three. It can be supervised learning, unsupervised learning, and reinforcement learning. So the example that I gave you now is supervised learning. Mother is next to the child, teaching the child that this is this, this is this. And every time when there is a wrong answer, she corrects the child by giving the correct answer. So it is a task-driven approach, and it helps in predicting the answers. And unsupervised learning is one where there are no expectations of the output. Say, for example, the child is just given some set of information, some set of data, some pictures, and they ask the child to categorize or group the data as she thinks is right. So that is called as unsupervised learning. No inputs given, no expectations of output. So that is called as, inputs given, but no expectations of output. So that is called as unsupervised learning. Reinforcement learning is like learning by mistakes or learning by rewards. Whenever the child gives a correct answer, the mother says, good, your answer is correct. She gives a pat or she says the word good. Whenever it says a wrong answer, she says, no, this is not wrong. So the baby tries to understand, whenever I give a correct answer, my mother is happy, she is giving me a reward. And whenever I give a wrong answer, the mother is not happy and she is telling me to correct. Okay, so based on the behavior of getting reward and getting punishments, the child tries to learn certain things. So that is called as reinforcement learning. So when do we apply supervised learning? We will apply supervised learning in cases where you are only trying to widely categorize or classify the problems, or when you have amount of labels which are there for you to give an expectation of the answer. So when I show an input to the system, or when the input is given to the system has an expectation on the answer. There is an expectation on the output. You're looking for a particular answer. So if I show the photograph of an apple to the child, I'm looking for the baby to give me an answer that this is an apple. So that there is a label attached and there is an expectation on the answer. So when you have such types of system modeling, you call this as supervised learning. Unsupervised learning is when there are no labels attached. Okay, you just give some set of group of information, a group of data, and the system tries to understand similarities from this group of data from set of features. So clustering and association learning are good examples of unsupervised learning. In a semi-supervised learning, this is unsupervised learning, we have lots of input information. There are certain features collected from each input data, say the shape or the size or the color or something. So given any input, the system tries to deduce its own set of features, applies it into the algorithm and gives you an answer. So this is unsupervised learning. Okay. Next is semi-supervised learning. Semi-supervised learning is mostly working on an unlabeled data and helping the decision making process with a little amount of labeled data or labeled information set. So that is called as unsupervised learning. The best example of a semi-supervised learning that we are, every one of us are using is the Google text expander. You start typing first few letters in the Google, the remaining words pop up. So that is the best example of a semi-supervised learning. Semi-supervised learning is widely applied in places like speech analysis, protein sequencing, and web content analysis. Next is reinforcement learning. So what is reinforcement learning? As I told you, there are no inputs. The child is allowed to learn by itself just based on the rewards and punishment it has. And the reward and the punishment can be helping us to classify reinforcement learning as positive reinforcement, negative reinforcement, punishment reinforcement, and extinction reinforcement. So what is positive reinforcement? Whenever I do an activity, people say it is good. So I understand that whatever I do is good. So I learn something. So this is positive reinforcement learning. Negative reinforcement, when I do something, I get a punishment. People say, no, don't do it. Okay. People are not happy with what you're doing. Say, for example, in a manager employee situation, sometimes the employee does something and the manager says, yes, good. It's a wonderful act that you have done. It is a positive reinforcement. A negative reinforcement, the employee does something, the manager does not give any feedback. He just leaves indifferent. So that is a negative feedback. Sometimes based on the act that of the employee, the manager punishes the employee. Okay, so that is called as punishment reinforcement. An extinction is there can be a situation when there is no more to learn, or the learning curve can come to a saturation where the system is not ready to learn anymore. So that is called as extinction reinforcement. Okay, so reinforcement is all about how the agent or the entity understands the situation and learns the situation based on reward and punishment. Okay, so widely we have classified our machine learning algorithms into supervised learning, unsupervised learning, and reinforcement learning. So whenever we have a classification problem, we apply these classification problems on diagnostics, image classifications, or fraud detection, and so on. Regression algorithms are used whenever we have continuous data available, like your weather forecasting or expecting life expectancy calculation of a patient. You want to find out how long this cancer patient will live based on the previous amount of data, or you want to forecast the market of a particular product. So all this can happen using supervised learning algorithms. In unsupervised learning algorithms, all our recommended systems, your Google search, your big data visualizations, whenever we talk about RNA, DNA, structure discovery, and all this, in all these concepts, we use unsupervised learning. Reinforcement learning, if you are developing a video game or if you are developing an AI game, then we are definitely using a reinforcement learning algorithm. Or when there is an AI robo generation or production, or when you are trying to apply a learning task or a real-time decision-making algorithm, then reinforcement algorithm or reinforcement learning algorithms play a vital role. So this is what we were discussing so far. So when you have to predict or classify, it is supervised learning. When you want to cluster or you want to estimate or you want to try to find out the associativity of features, or if you're trying to apply dimensionality reduction, reduce the number of features for a decision making process, then it is unsupervised learning. Okay. Okay, so this is what we were discussing so far. So classification, you will have labels, you will have the labels imposed on the unseen examples, and you will be coming out with a decision. Regression, whenever you have a continuous input value and output value expectation, when there is a dependency of variables. Association, when you try to find out associativity between items. The most important or the very frequent example that we study is the a priori algorithm, which is used in the market basket analysis. So in a supermarket, you want to find out which two products are closely associated. and I want to place my products accordingly, or I want to do my business accordingly, then I have to be using association algorithms. When it comes to grouping, then it is clustering algorithms. So whatever I told you so far, I just tried to put it as a machine learning process. So you collect the data, data acquisition, you process the data, then from the data, the system tries to extract certain features like color, size, or any feature, even in an image, feature points, all that is collected. Then it finds out which feature is more important, which feature is less important. A ranking is done based on the ranking, it selects the right feature. Then there is dimensionality reduction done. Build the model, make the model learn, check whether the model that I have built is right, and then generate results. And when the results are generated, you find out whether the results are acceptable to me. If yes, you go in for the actual building of the system. If no, we have to reiterate the entire process. So it's all about training and how good you train and how good you test. And we always don't want errors during the training and testing phase. We want our system to be perfectly trained and perfectly tested to reduce the amount of error during the validation phase or during the deployment phase. So it is always a free lunch rule. There is no free lunch rule saying that you can have only this type of distribution or this. There can be no biasing available. The data should not be having a high variance. It should be optimal. Okay, biasing and variance of the data should also be optimal. Okay, so all the results of this machine learning systems are majorly dependent on the performance of certain factors. What type of training are you giving? Are you using the right model at the right situation? Okay, and then how much amount of data have you collected to feed into your system to make your system understand and learn? And what type of feedback are you giving? When the system gives you a right answer, are you saying yes, it is right? When the system is giving you a wrong answer, are you giving a feedback that the system is wrong? Okay, and what type of learning algorithms you are applying? And whatever we do, the most important factor is optimization of the answer and the best modeling technique that is being applied. So across the globe, people are talking about machine learning in actually different words and in different analogies. They try to say building a brain like a human being using neural networks, okay, applying it in neurobiology, or they say mimicking the human memory as case-based reasoning, or they are applying it to genetic algorithms in the evolution of genetics, or they use it as rule induction. They say machine learning is all about rule induction, generate rules and the system acts based on the rules. Or it can be simple mathematical application like analytical methods. There are varieties of machine learning which is happening in different names across the globe. As we discussed, our reinforcement learning, explanation based learning, genetic algorithms, evaluation functions, macro learning, all these are forms of machine learning. If any of us are working in any of these fields, then indirectly it means that we are working in the field of machine learning. So your machine learning algorithm can be used in a black box learning where you know what is your input, what is your output, but you are not able to comprehend what happens in between, like how a human brain works. You can never write rules of how your brain works to come out with decisions. So in such situations, you apply machine learning. When there is a transparent box, exactly the opposite. When you know what happens in the decision-making process, and the decision-making process is a detailed process, then yes, we apply machine learning. And also case-based reasoning. See, the same solution cannot be applied to the same to every student in my class. One student understands better in the first time of explanation. The other students has got problem in understanding. I have to explain him twice. So depending on the case, the learning differs. Similarly, the system can also develop such a behavior of learning. So that is called as case-based learning. So we have seen these examples. So these are the wide variety of applications of machine learning, our search engines, social media, online customer support, video surveillance, fraud detections, then translation. Google Translator is a good example of machine learning. Okay. So these are some examples or some applications where machine learning touches our life every day in and day out. Walmart is managing its 20,000 square feet supermarket with just one alpha robo. So this alpha robo is a machine learning or AI system which has machine learning algorithms inbuilt. So it does the inventory management, it does the packing, it does the delivery. Okay, pricing, checks, and delivery. So every day, twice, the robo scans through the entire aisle of the supermarket to find out which products are missing, which products it has to refill. Gives this data to the owner, he refills. Then whenever there is an order placed on online, immediately it does all the packing. So there is only one person for a 20,000 square feet supermarket, is magic, which sounds to be magic now, but which will become a very, very common phenomena in the very near future. And now we have restaurant run robos and run by robos. Robos act as chefs, robos act as waiters. Even in India, we have one or two restaurants in Mumbai which are AI enabled. So you give an order for a food, the machine learning system will get information about who you are, whether you're diabetic, whether you have high blood pressure, low blood pressure. It scans all data about you from your card payment, and then it cooks the food according to your taste. Okay, according to your need. Okay. Then this is a very good example that we are very widely using here. And Uber, and there is another service called Ola, which is available only in India. So Uber has got its own internal machine learning service platform, and this is called as Michelangelo. So if you have been using Uber, at the time of demand, there is a different cost. At the time of surges, there is a different cost. And whenever there is a traffic, it shows you an alternate path. So all these are the best examples of a machine learning algorithm working in your day in and day out. Your Spotify, if you have been using Spotify for a very long time, you know that it understands your mood, your interests, and it gives you song recommendations based on your moods and interests. And all of us are researchers, so definitely we are all bothered about our Scopus indexing, Web of Science indexing, searching papers from Thomson Reuters, and so on. So Thomson Reuters is using a machine learning algorithm which helps in data unification and data acquisition. So it gives you which of your papers are very widely referred, which are not, and so on. So the entire data acquisition happened from a company called Tamar, and they have gone in for unification, and they have gone in for a machine learning algorithm. This GlaxoSmithKline is a company, all of us know it's a pharmaceutical company, based on the feedback of mothers giving about their children, that my child is allergic to this, my child picked up this disease now, and so on. They have come out with customized vaccines for children. So one vaccine, not to every kid, depending on the kid's behavior or depending on the kid's genetics, they have developed a specific vaccines for specific set of children. So that is the amount of machine learning which is happening. Even in frequent papers and researches, I read that there is a lyric writing application available in Indonesia, which is widely used. And it is also said that if there is a startup which has to be working on AI, then Indonesia is the right place to have all those startups coming up, because there is a garbage collection app also which is working now with you. And Amazon Go, this changed the entire business. Now Amazon Go is what in Indian companies in India, we are trying to use Amazon Go to the maximum, or at least try to relate the marketing behavior of Amazon Go now. There are a number of applications which are under research, which are cheaper to Amazon Go, and we are trying to at least make something very similar to it, because we have number of shops here and everything is not completely corporate. So at this time of pandemic, we are looking for business solutions which can help the entire marketing situation with the social distancing. Okay, and with the chatbots, you have chatbot for everything. You can search on the internet and get chatbots for every domain of your regular living. So all these chatbots are results of machine learning algorithms which are working behind. Okay, all e-commerce chatbots, all Facebook chatbots. And with Internet of Things picking up, when every device becoming a smart device, you have large amounts of data which is getting collected, and from all this data, definitely we need knowledge. And so machine learning is the next big thing, working on it. Yeah, these are very good examples of personalization. I hope all of us know about Sophia, the social humanoid robot. But 3 years after Sophia, now Sophia is now becoming outdated. I think people have started are working on a research which is an improvised version of this. All of us are using Google Assistants, which is an example of machine learning. And this Amazon Alexa machines and Nexa, which we use in our homes, is an example of a very good example of a personalized machine learning application. Okay, so these are some personalization platforms which are widely used. I've taken examples which are widely used in India and abroad. So you take any landscape, you take manufacturing, retail, healthcare, travel and hospitality, or financial services, or energy feedback in utilities. Every field has got machine learning algorithm applied in it. So we are entering into an era where machine learning is mandatory for any product. Now, customers are looking for attribute in your product, which is also self-learning. And with so much amount of information which is being invested into robotics, yes, machine learning has got a wide area of scope in the next coming years. Now, we have started moving from talking from machine learning to deep learning. Now, are they completely different? No, they're all one and the same. But the only thing is, in artificial intelligence systems, we try to mimic the human behavior. In machine learning, we develop algorithms which can act and make decision making on their own. And in deep learning, we are fine tuning this decision making process by increasing the amount of knowledge and decision making by increasing the number of levels of feature understanding. Okay, so in a normal pattern recognition, you give some set of features, the classifier will tell you what picture it is, or so on. But when you use a little of machine learning, then it starts identifying some mid-level features also. In deep learning, it becomes more hierarchical and more trained, that we go in for number of levels, say 30 levels, 40 levels of understanding various features, and your training and classification becomes more specific and more clearer. So that is the kind of improvisation that we are looking for. As I told you, anything you take in any field, you are going to have machine learning algorithms running behind. So I have just collected to this picture just to show you that any field that you talk about across the globe, everything is inclusive here, be it agriculture, education, finance, medicine, image recognition, prediction, NLP, retail, everywhere, augmented reality, everywhere you have machine learning algorithms playing a major role in the improvisation process or in the decision making process. So it is said that artificial intelligence have got 3 levels: the weak level, the strong level, and the super intelligence. And researchers say that we are still in the weak level, and there is a need of improvisation in machine learning algorithms for us to move from weak level to the strong level. So machine learning algorithms future is this strong AI and moving on to super intelligence AI. So there is a lot amount of research happening to improve unsupervised learning algorithms. And personalization is what we are looking for. So enhanced personalization is going to be there. Every individual who is working on the internet, or every individual customer, is going to be targeted with products of his or her own interest. And with quantum computing coming all away, okay, with so many smart devices around, you need a lot of cognitive services. And as I showed you in an example, robotics is picking up. Sophia was one example. Now people are going to start forgetting about Sophia, and there are going to be number of such robots, humanoids, which are going to come into picture. And all this will be the future of machine learning algorithms. So this is our Gartner's predictions. It is just a collection of whatever I told you so far. So AI is the upcoming field. Because of AI, we have a machine learning algorithms. And every smart device, every device, electronic device across us that we come across is going to become intelligent. All information is going to go on the cloud with a lot of chatbots, augmented reality, virtual reality concepts coming in. Machine learning is going to play a major role in the future. And when you have a lot of information on the future, definitely there is going to be a security problem. So blockchain is also going to have a lot of boom. Already number of countries have started using blockchain, but we are still only in the primitive stage. There are number of steps to go on. So if I'm a person who is interested in machine learning, there are some tools that I should mandatorily know. TensorFlow is what the world is talking about. When you compare to Scikit, PyTorch, and Vega, TensorFlow is a better tool which has got all of inbuilt library, and it allows you to work on multiple platforms and with multiple set of information. Then we have Colab. If you are a student and if you have to work on cloud services, practice machine learning algorithms, then Colab is the best solution. If you are a researcher, you can go into NIME or a course. If you are planning to get into reinforcement learning kind of algorithms, or you're planning to work on deep learning neural networks, then Keras and Oryx 2 is the best tool to apply. So we have almost come to the end. We did discuss about artificial intelligence, deep learning, and machine learning. I just tried to show you where we are and what is the scope of machine learning in the near future. If we are people who are not getting it, okay, if you're not into the field of machine learning, I would suggest that you better get into it, because in 3 years of time, all of us will become dinosaur, meaning we have nowhere to go. All of us will extinct, because the world tomorrow is only about machine learning, artificial intelligence, and deep learning. So we have to be part of the race. Thank you. If there are any questions, I'm open for the questions. I'm open for questions now. Thank you, Dr. Susanna. Hello.
Yes, ma'am. Okay, thank you so much for the presentations. I think, what is it? Machine learning and artificial intelligence now is very useful, particularly when we have in the pandemic right now, and also, what is it? During the crisis, in the future crisis, then it is very useful. Okay, thank you very much for the presentations, Dr. Bharati.
Thank you, Susanna.
Yeah.
For this.
Yeah. Okay. We open the what is it? We open the question and answer session now. If you want to ask question directly to Dr. Bharati, you can click the raise hand in the Zoom application, so we can unmute your microphone, so you can ask her directly. And while we are waiting for the questions, I have questions in the chat box. How to interconnect machine learning with IoT?
Okay, every IoT device, now we are talking about something called as fog computing, where every IoT device itself is trying to have the capacity of evaluation. Okay, so whenever data is collected in a particular device, evaluation also happens in the same device. But complete using of the entire machine, dumping the entire machine learning algorithm into the smallest sensor device is not always possible. So the IoT device can be so the IoT device can be a mode.
Follow and subscribe.
You are inaudible, ma'am.
Hello. No.
Yeah.
The IoT device can be a mode of data collection, and all this data can be collected and stored into a cloud or a computing device, and there is where you apply a machine learning algorithm. Okay, so connectivity to an IoT device to the computing device is normal networking, and machine learning algorithm decisions can be sent back to the IoT device. Have I answered your question?
Is that answer your question, Mr. or Miss Sasikala? You can type in the chat box. Yeah. Yes, it's answered the questions, ma'am. Thank you so much. And another questions from Fadin?
Okay, thank you. It's nice to see you, Dr. Parati.
Thank you, Mr. Radin.
So, I see that you have described the difference between deep learning, artificial intelligence, and machine learning. But I just wondering about a blockchain technology. How does blockchain contrast with machine learning algorithm? So if you don't mind, you can. I need maybe some example. How does this blockchain technology can contrast with machine learning algorithm? Thank you.
Okay. Machine learning algorithms and blockchain are actually two different aspects. Blockchain is all about security, the cyber security. You're going to store a lot of information on the internet, and there are going to be machine learning algorithms which are helping you in the decision making process. Now, during these transactions, you want the transactions to be fraud tolerant, or you don't want fraud to happen during these transactions. So blockchain is a methodology by which you have a decentralized control on the network to avoid fraud. So if I make a transaction with you, whatever transactions I make, we both will have the same copy. Okay, so there is going to be a ledger maintained on what are the transactions that we have performed. So a fraud trying to change the available data will not be possible. So that is blockchain. And machine learning and blockchain are completely two different perspectives. I mentioned blockchain because I was trying to say what are the future techniques which are going to be available or which are going to prospect in the next future. So I also mentioned blockchain there.
Okay, thank you, Dr. Parati. I'm sorry, one more question. Is it okay?
Yes, yes, please.
Okay. Imagine if you want to learn machine learning on the first place. If you want to learn machine learning,
okay,
for the beginner, like me, what will you do? What will if because I look at that machine learning course, it's like it's too many for learn something, just like a data mining, like a big data. What will you learn first if you have to learn machine learning on the first place?
Okay. My perception, you would start with the data mining. Okay. Then you will understand, when you study data mining, you will definitely understand database technologies. Okay. Then you will move on to machine learning after understanding data mining and data science. So as I told you in the slide too, machine learning is a combination of so many fields. So you will start with the data mining and then move on to machine learning.
Okay, so data mining and data science is the same term, same thing?
No, they are not same. They are the same, but they are not the same. They have their own differences. Data mining gives you methodologies of information generation from data. Okay? Data science is all about analytics of the data and also involves prediction. You talk about description, prediction in data analytics. So grade 1 is data mining, grade 2 is data science.
Okay, Dr. Parati. Thank you so much.
Thank you so much.
Yeah, okay. Is there any questions from the participants? Oh, okay. There's another questions from Miss Cynthia.
Yes.
So you want to ask directly, yeah? Okay.
Okay. Hello, Dr. Parati.
Hello,
It's
Cynthia.
really nice to have you here and share a knowledge with us in here. And thank you for the presentation. I'm Cynthia, currently researching on the machine learning and deep learning in the Sunmun University, Korea.
Okay.
If I may, I would like if you can share like your recently field of research in machine learning that you been research lately, because we know that the machine learning and deep learning is really a broad field, and I really interested to know what kind of field that you have been researching nowadays. Thank you.
Thank you. I don't. Hello.
Yes.
Yes. I think there is a lot of noise on the line.
Maybe Ma'am Suzanne can mute.
Hello. Okay. Cynthia, I don't have a paper to immediately show you, but I'll tell you what work we are currently doing in my place here. Okay. Okay. I am working on a device which can understand the behavior and requirements of a paraplegic patient. Okay. A paraplegic patient may be a person who has who cannot move all his limbs, and who also have problems in speech. So we are working on a product. It's a assistive technology. I would say it's an assistive technology, and we have also applied a patent in India. There are 3 stages in the patent. We have applied, we have published, and we are waiting for the grant. I may get it in the other 2-3 months. Okay, so I will become a patent holder. So my system is the patient wants, because the patient cannot talk. Okay, and he cannot move his hands or legs. He's completely bedridden. Okay, or there are patients who have brain stroke, who cannot move. So we are trying to build an assistive technology where there will be the system or the assistive technology can be used only by their eye blinks. Okay, so if we have a sensor which continuously, I am talking about IoT. So I have a sensor which will be continuously noting down details about the patient. So it will try, we are applying a machine learning algorithm. We are applying a deep learning algorithm here, and we have just gone till 5 levels so far. Okay, so we are trying to identify what is the mood of the patient, what is his need now. Okay, is he under distress, or is he in need of any attender to immediately come and attend him? Okay, likewise. So based on that, the assistive technology will help him to move or ask for help. Okay, we are working on the prototype also, and we have applied for a patent. So this is my current research.
Okay, thank you, ma'am, for the share. I hope it is gonna be success, and I gonna wait for your published paper.
Thank you. Any more questions?
Yeah, any more questions? Dr. Parati, I have one question on the chat box from Dr. Wahyu. Beside the future of machine learning, as you are mentioned, is there a dark side of machine learning?
Dark side of machine learning, I would not say it's a dark side of machine learning, because every device is starting to collect data from all of us. Our privacy is completely lost. So if I should say dark side of machine learning, lost privacy of us is the dark side. because all information is freely available. Even now, Zoom is listening to me. It is trying to understand what type of information am I sharing here, because I'm giving my mail credentials to log in and log out. And from the mail, it is going to understand what are my basic features and what is my interest, what I generally search in Google. All that comes through my mail because I'm logging into Zoom. And when I start collecting data from all these online channels and online devices, my privacy is gone. So losing privacy is the most important dark side of machine learning.
Yeah, okay. So that is the dark side, losing the privacy. Okay,
Yes.
so it means that we need to be very careful protecting our privacy and our data, right?
Yes, ma'am. Yes, yes.
Yeah, okay. Okay, so I hope that it's answered your questions, Dr. Wahyu. Okay, before I share the, what is it, the exit ticket, I would like to say thank you, Dr. Bharati, for the presentations. And it's very useful for us related to the machine learning. And before we end, I would like to invite Dr. Eva Handriantini to give a speech of this webinar. Ibu Eva, the time is yours.
Okay, good afternoon, everybody. Thank you, Ms. Susan, to arrange this webinar this afternoon between STIKI and Satya Bama Institute of Science and Technology from Chennai, India. And this is the first collaboration between us. And also I'm thank you so much from Dr. Bharati for your sharing. This is the nice presentation, and we have knowledge more about machine learning. And also thank you for Mr. Adin from STIKI Malang. And I hope this is not the last of the collaboration between STIKI and Satya Bama. And I hope we can arrange another subject for the next webinar. Thank you so much also for all the participants this afternoon, and I hope this knowledge can improving our knowledge in our education, and we can share the best for our students. Thank you very much, and good afternoon for all.
Thank you. Thank you so much for the invitation and the opportunity. Thank you on behalf of our university also, representing me as a part of our university. Yes. Thank you so much, ma'am.
Yeah.
Dr. Aden, thank you. Thank you for being a listener. Thank you so much.
Yeah, we will, for the, what is it, for the material or of this webinar, all the participants can access or can get it from our YouTube channel, STIKI YouTube channel, because this webinar is streaming in a YouTube channel. So you can get the materials or this video from YouTube. And we will share the, what is it, the exit ticket link, so you can record your attendance and also to get your certificate. Please type your name, check your name and email correctly, so we can deliver your e-certificate also in a correct name and a correct email. Thank you.
Thank you.
Thank you for Dr. Bharati and also Mr. Adin Aditya and also Ms. Susan. I will inform you the exit ticket can be accessed until tomorrow before we end the webinar. Let's have a photo session with the speakers. Please turn on your camera and give your beautiful smile. Please hold a minute. Ivan.
Next one.
Please hold a minute. Okay. Thank you. We have taken all your pictures.
Thank you. Thank you.
For more information about our next webinar, you can get the information on our Instagram at Stiki Malang, STIKI Malang. And also, you can subscribe our YouTube channel for more live streaming webinar at Stiki Malang. We would like to inform you that Stiki Malang has international webinar series 4 in collaboration with Pangasinan State University of Philippines on Wednesday, June 17, 2020 at 10 a.m. The theme of webinar is Pedagogy and Learning Competency. The registration is still open until June 16, 2020 at 12 p.m. You can find the details information on the poster sent in the chat box. On behalf of Stiki Malang Indonesia and Satyabama Institute of Science and Technology, India, we would like to deliver our gratitude and appreciation to all participants and see you in the next international webinar series.
Yeah, okay. Thank you very much for the participations, and I invite you again to join our international webinar series on Wednesday, 17th June 2020. Our registrations will still be opened until tomorrow at 12 p.m. Thank you so much for your attendance and your participation in this webinar series. The certificate will send to you within 10 days. Thank you very much. Thank you very much, Dr. Bharati. and Mr. Adin.